Right, in this video clip we'll work through the first 40 marks of the WJEC Intermediate Paper 1 from November 2017 and we look where the first 40 marks are. As usual, if you can maximise or get full marks for those first 40, then you're certainly guaranteed to get at least a grade C. So the first 40 marks, we have 7 there, then another 3, 17, 20, 26, 35, 40. So if we get to the end of question 7 with full marks, then we're there. If you can get to question 7 with as many marks as you possibly can, then everything you gain from there is just going to boost your chances of getting that C or taking the pressure off you in paper 2. Okay, so question 1. Calculate each of the following. 3 to the power of 4 times 10 to the power of 3. So you need to remember that raising to a power means you're multiplying it by itself 4 times. So that's not 3 times 4 is 12, that is 3 times 3 times 3 times 3. 3 3s are 9, 9 3s are 27. Then you're going to do 27 times 3. If you're not confident doing that without a calculator, then go and work it out. 7 3s are 21, 2 3s are 6, and another 2, 8. So that's 81. 10 cubed is 10 times 10 times 10. 10 tens are 100, 100 tens are 1000. So to work out 3 to the 4 times 10 to the 3, what we're actually doing is 81 times 1000, which is 81,000. And there's 2 marks for that. Basically 2 marks if you get it correct, but you'd get 1 mark for either getting 81 or 1000. So it's things like that that's important that you do your work, you show your methods and your intermediate workings before just putting the answer. There's lots of different ways of doing 1 over 0.5, but probably if we think of it as an equivalent fraction, we can make life easier for ourselves by getting rid of the decimal underneath. We can do that by multiplying by 10. We have to, in order to keep the balance of the fraction, if you multiply the bottom by 10, you have to do the same to the top, just as with equivalent fractions. So what you then get is 1 times 10 is 10, 10 lots of a half is 5, 10 over 5, 10 divided by 5 is 2. So 2 is the answer to that. Lots of different ways of going about that. With this one, I would expect most people would lay that out as a column subtraction, and it's important that the units and all the corresponding columns align correctly. So 5 is the unit, 3 is the units, 0.82. So that's the subtraction we're going to do. Where there's a gap there, we can add a 0, and then we go from there. 2 from 0 we can't subtract, so we take from the next column. So we write it as 5010 rather than 60. 2 from 10 is 8. Now we can't take 8 from 5, so we have to borrow from the adjacent column. So rather than writing 56, we write it like that. 8 from 15 is 7, and 3 from 4 is 1, so 1.78. Just 1 mark for that. With this one, we're back to equivalent fractions. I can't subtract them until the number on the bottom of the fractions, the denominator, is the same. I can turn that into sixths by multiplying both top and bottom by 2. So what I end up subtracting is 5/6, take away 2 2s are 4 over 6. when the denominator is the same, we subtract the numbers that are on top. And then you don't subtract the numbers on the bottom. All they do is tell you what the fraction is out of, that we're working in sixths. 0.2 times 0.3. 2 3s are 6. And then you count the number of digits you've got after the decimal point in the question, and there are 2, which means there needs to be 2 digits after the decimal point in your answer, which means you have to pad that out with a 0. Another way of doing that would be to change them into tenths. 2 tenths times 3 tenths, which would be 6 hundredths. And 6 hundredths is the same as 0.06. If you did it that way, you would then need to write it back in the decimal form. Okay, so on that page, 2, 3, 6, 7 marks there already, and if you are aiming for at least a C, there shouldn't be anything on that page that you're uncomfortable with. Question 2. Circle either true or false for each of the following statements. G times G times G can be written as 3G. Well, if you just flick back to the previous page, if you're multiplying by itself, it's to the power of how many you're multiplying by. So G times G times G would be G cubed, not 3G. 3G would be what you got if you were adding the G's together. So that one is very much false. The expression 7y take away y can be written as 7. Well, 7y take away y, what you're doing is, that's a 1y, so you're doing 7y take away 1y, which is 6y. You're not removing the variable y, so that is false as well. A divided by 4 divided by A equals a quarter. Okay, so this one will depend on how you've been taught to deal with fractions. So I'll give you a couple of different ways of thinking about this. If you've been taught to divide with fractions by turning the second number upside down and multiply, this is quite straightforward. Even though we haven't got a fraction there, we can write that one as A over 1, because if you divide anything by 1, you end up with the same thing. So we can write it as a fraction like that, and then if you're comfortable with how you've been taught that to deal with that, you change what you're dividing by into a multiply by inverting it or multiplying by its reciprocal. Then you get that. If you can deal with multiplying fractions and dividing fractions like that, you'll also see that you can cancel those two out, leaving you 1 over 4. So it's true. Another way you can go about that is by trying putting different values in. So if you're not comfortable with that, try, if A is 1, you'd have 1 over 4 divided by 1. Well, if you divide anything by 1, you get the same thing. So it would work for that. A equals 2, you'd have 2 over 4 divided by 2. Well, 2 over 4 is the same as a half. If you're dividing by 2, you're halving. So that's the same as a half of a half, which is a quarter. So whichever way you come at it, that particular statement is true. A over 2 plus A over 2 is A. So that's the same as a half plus a half, which is 1. Or if you've got A over 2 plus A over 2, remember you can only add the fractions if the denominator is the same, which they are. So you'd end up with A plus A is 2A divided by 2. 2's will cancel, leaving you A, which is true. And then the final one, when A is 1, B is 2 and C is 3, A plus B plus C equals ABC. So A is 1, plus 2 plus 3 equals A, B, C. Now it's important to remember with algebra, if there's no symbol between any letters, there's actually an arithmetic multiply there. In algebra we don't put it in, but as soon as we change from algebra to numbers, we have to put the multiply in. So that's going to be 1 times 2 times 3. 1 plus 2 is 3 plus 3 is 6. 1 times 2 is 2 times 3 is 6. So that is true as well. So you're looking for false, false, true, true, true. And it's important when you're doing questions like this, don't just guess, or even don't just think, well, I may know that, or whatever. Use this space to test the statements out. Put what you know in. Question 3. In this part of the question, you will be assessed on the quality of your organisation, communication and accuracy in writing. Now what that means is you have to communicate clearly what you're doing and be consistent with the units you are using. There's no expectation for you to write an essay. So you'll see when I work through this now that I'm not surrounding, it's not going to be sentences and loads of words. It's just going to be clearly stating and carefully laid out. So the two cuboids shown below have equal volumes. So we have one cuboid A, 6 by 2 by 3, and cuboid B, 2 by 2 by some value h that we don't know. Calculate the height h of cuboid B. You must show all your working. They have equal volumes, so we're going to be working with volumes. So the first thing I'll do is work out the volume of A. So to work out the volume of A, again, you're a grade C or grade B grade candidate. It's fairly straightforward. You should be able to recall that to work out the volume of a cuboid, it's length times width times height. 6 times 2 times 3. 6 2s are 12, 12 3s are 36. And here now it's important that you put the right units in. The units are in centimetres, so the volume is in centimetres cubed. Now the volume of B is 2 times 2 times h. So I don't know h, but I do know that 2 times 2 is 4, so I can write that as 4h, consistently using the units. Then I'm going to say these volumes are equal. Of A equals volume of B. So 36 equals 4h. So what you're trying to do is say, well, what am I going to multiply 4 by to make 36? The answer is 9. 4 9s are 36. So the height of cuboid B is 36, and the units will be in centimetres. And that's it. That's all you need to do as far as those two OCW marks. I'm not writing a story. I'm explaining what each line of maths is. So I'm not just randomly multiplying 6 by 2 by 3. I'm showing quite clearly that I'm doing that because I want to find the volume of A. I'm doing the same thing for volume B. The question's giving me this information, that they have equal volumes, and I can use that to form an equation and work out what the height is going to be. And I've got that wrong as well, haven't I? The height is 9. 4 times 9 is 36. So I wouldn't have got full marks unless I stuck around to talk through what I'd done. So the height is 9 centimetres. Part B. How many cubic centimetres are there in 2.5 litres? So the fact you need to know is that 1 litre is the same as 1,000 cubic centimeters. So to get 2.5 liters, you're going to be multiplying by 2.5. One lot, so 2.5 is 2.5. So to maintain that balance, you have to multiply that by 2.5, which is going to be 2,500. So 1 litre is 1,000 cubic centimetres is a fact that you need to learn if you don't already know it. Question 4. A fraction is written as a over b. The fraction is a multiple of 0.2. The fraction is greater than 1/2, and the fraction is less than 75%. Write down the fraction as a over b, where a and b are whole numbers. So this is a slightly different twist on a question which comes up on lots of past papers, where you have to get everything in fractions, decimals or percentages to compare. Because we want this in fractions, the easiest thing to do is to turn that 0.2 into a fraction. As a fraction, 0.2 is, or what we could do, hold on, it's a multiple of 0.2, so we've got 0.2, 1 times 0.2 is 0.2, 2, 0.4, 3, 0.6, 4, 0.8. It's greater than 1/2. Well, I know that 1/2 is 0.5, so that's going to knock those two out. And it's less than 75%. Well, 75% is 0.75, which knocks that one out. Which means, as a decimal, that's my number. And 0.6 I can write as 6 over 10, or I can write it as 3/5. Either of those would be correct. So 6/10 or 3/5. Question 5. Write down the next two numbers in the following sequence. So we look to see what is happening, what's changing between each number in the sequence. In the first case, it's gone down by 1. In the second case, it's gone down by 3. In the next case, it's gone down by 5. So I can see that it's falling by 2 every time, or it's going down in odd numbers. So the next difference will be taking 7 off. So 13 take away 7 is 6, and then we're going to take 9 off, and 6 take away 9 is negative 3, sorry. Negative 3. Expand 5 bracket 3x minus 2. So when you're in expanding brackets, you're multiplying, because we're in algebra. If there's no sign between the 5 and the bracket, there's a times there. So I'm going to be doing 5 times 3x is 15x, and then 5 times 2 is 10. To deal with a sign, there's no sign in front of that, which means it's positive. That's negative. Plus times a minus is a minus, is one way of remembering it. If the signs are different, the answer is negative, is the way that I teach it, giving us 15x take 10. Part C, this is an equation. It's got unknowns on both sides. What you do to one side, you have to do to the other. So to get the x's on one side only, I'm going to take that 4x off, which means I have to take 4x off there as well. That will leave me 9x take away 4x, 5x plus 3 on the left hand side, and on the right hand side The 4 x's have gone, leaving me 5. Now I'm going to take that 3 off, which means I have to take 3 off the other side as well, leaving me 5x equals 5 take away 3, 2. And then no sign, which means it's 5 times x, so I have to do the opposite of timesing by x, which is dividing by x, dividing by 5. So 5 divided by 5 leaves me 1, so I've got 1x, and on this side 2 divided by 5 I can just leave as a fraction. So that's the way that I would deal with that. There are other ways. You could take 4x straight off each side without those methods. Whatever works for you, however you were taught. Question 6. Sarah is in charge of a game at her school's Christmas party. 2 fair spinners are spun, as shown in the example below. People can make a 2-digit number using the numbers shown on the spinners using the following rule. Multiply the number on the first spinner by 10 and then add the number on the second spinner. One example, as shown above, makes the number 21. So multiply that by 10 and you get 20, and add that you get 1, 21. How many different numbers can be made playing this game? Well, if the first spinner is 1, the second number could be 1, so that which would give me 10 and 1 is 11. Or the second number could be 2, so it would be 10 and 2 is 12, or 10 and 3 is 13. The second number is 2, would give us 21, 22 and 23. And if the first spinner is 3, it would be 31, 32 and 33. So how many different numbers can be made using this game? 9 different numbers. Right, so all the prime numbers that can be made playing this game. So prime numbers are numbers that only have themselves and 1 as factors. I know that the only even number that's prime is 2, so I can knock out all the even numbers there. I know that 7 goes into 21. I know that 11 goes into 33. But the rest of those numbers then are prime. 11, only itself, 11 and 1. 13, 13 and 1. 23 doesn't sit in any times table, and neither does 31. So all the prime numbers will be 11, 13, 23 and 31. What is the probability that a person makes a prime number when playing the game once? So for probability, the number of outcomes that satisfies that would be prime number 1, 2, 3, 4 out of the total possible outcomes for the game, which is 9. So 4/9, 4 over 9. Part D. Sarah charges each person £1 to play the game once. Each player who makes a prime number from their spins wins £2. How much profit would the school expect to make when 180 people play the game? So games of chance, there's loads of these on my website. If you go and look under topics for games of chance, well worth practicing because they carry quite a lot of marks. So everybody who plays the game pays £1. So that means coming into the game earns 180 lots of £1. So if nobody won the game, they'd make £180. But the chances of somebody winning the game is 4/9. That means every 9 games you would expect 4 winners. That's not to say guarantee, but expect. So the number of winners will be the probability of winning times the 180 people playing. So 4/9 of 180, non-calculator paper. So hopefully you can see, well, 1/9 will be 180 divided by 9, which is 20. So that will be 4 lots of 20, which is 80 winners. So 4/9, that comes from the probability of winning, which we've already worked out in part C, times 180, because there are 180 players. So then you work out 1/9 by doing 180 divided by 9, which is 20, and for 4/9 you'd multiply by 4. Now each of those winners wins £2. So the game pays out £2 lots of 80. 80 winners, £2 is £160. So everybody who plays pays. So as 180 comes into the game, but we can expect that game with that chances of winning to pay out 160. So the profit will be the difference between what comes into the game and what pays out of the game, which is £20. Like I said, that's a very predictable solution there. So if you think, well, I can have a go at that, go and practice them on my site. Games of chance. And the final question for our 40 marks, for the first 40 marks on the paper, is this one. ABCD is a quadrilateral. You need to know that that means it's got 4 sides. And also, quadrilaterals always, their interior angles add to 360. So that trigger word there, quadrilateral, is important. 4 sides, interior angles add to 360. If you recognize that, this is a pretty straightforward question. Angle ABC is 93. The ABC, the angle, is the one that's in the middle letter, where you're going from A to B to C. A to B to C, you're turning through that direction, so angle B is 93, BCD is 122, and ADC is 85. Points P and Q lie on the quadrilateral as shown, such that AP, that distance, is equal to AQ. So I can put a little line on each of those to show that that distance is equal to that distance. Prove that triangle APQ is an equilateral triangle. Equilateral triangle, there's another trigger there. You need to know that that means all the sides are the same length and also all the angles are the same size, and they're all 60 degrees. You must show all your working. So first of all, we need to work out what this missing angle here is. So to work that out, first of all, we'll add these together. So I've got 122, 85, 93. 8, 10, 10, 20, 2, 3. 300 degrees. So now angle DAB, which is this one, would be 360 degrees less 300, which is 60 degrees. So I know that that one is 60. Well, that's good, because I know that what I want is to show that they're all 60. Now, because AQ equals AP, put those little lines on, hopefully that should trigger, oh, that might be an isosceles. And if it's an isosceles, the angles at the bottom are equal to. Which means angle AQP equals APQ. Take that away from 180. Equals 120. So those both have to add up to 120. Divide by 2 equals 60 degrees. So that means that AQP is 60, APQ is 60, and DAB or QAP is 62. So they're all 60 degrees. Therefore, all angles in triangle APQ are 60 degrees. So it is equilateral. So the triggers there, although it looks a confusing question, you've got a quadrilateral, you need to know the properties of a quadrilateral. It's 4 sides and all the angles inside add up to 360. You need to know what the properties are in an equilateral triangle, that all the angles are 60 degrees, and then that the fact that AQ and AP are equal in length means that those angles there are the same. So that enables us to work out each of those is 60 as well. So there you go. If you can deal comfortably with all of those questions, you are well on to a grade C.